Okay, so we're looking at global average absolute sea level change here. This is from Wikipedia, and we're looking at the sea level change on the y-axis in inches, and on the x-axis we have the year, and this data is from gauges and satellite measurements. And so what I wanted to look at is you look at this curve here, and you want to see how linear is this and how much of this is an exponential growth curve. And in order to do that and look at that, I went to Excel over here, and you can see I eyeballed each of the years that we hit 1 inch of sea level rise, 2 inch, 3 inch, 4 inches. So for 1880, we started at 0 inches. 1895, 1 inch. 1920, 2 inches. 1945, up to 3 inches. 1953, up to 4 inches. 1972 at 5 inches. 1985 at 6 inches. 2000 at 7 inches. 2006 at 8 inches, and it looks like 2016 we are going to hit 9 inches of sea level rise. So here's the data that I grabbed from this chart. Just like I said, this isn't super precise. I'm just eyeballing the graph here, but I think it's pretty accurate. And so here we are in Excel, and here's all that data. And then down below, I have that same data just with the X and Y axes switched just for Excel purposes. And so first I looked at the data with a linear trend line, a linear regression. Okay, this is simply written as the trend equation in Excel. And what it does is you pull the data from, in this case I said linear at 1895, so you can't start at 0, you have to start at 1. So I went from 1895 through 2016. I had it analyze that data, and then based on that linear trend line, look at when it would hit 10 inches, 11 inches, 15 inches, 24 inches, 36 inches. And here are all the years. Okay, and I did that same thing, except down here I just looked at the data from 1953 onwards. And from here, I looked at the data just from 2006 to 2016. So just 2 data points for this last one. And you can see, let's just go to the 36 inches of sea level rise. With linear at 1895, we would hit that 2,422. That would be the year. This is the year here, I should say. And over here, we have the year. Excuse me, 36 inches at 2,422. And then if I look at the data from 53 onwards, it's 2,352. That's the year. And then looking at 2006, it would be 2286 would be the year. So you can see if you look at linear data, the further along in time you go, the sooner you hit higher amounts of sea level rise. So what this tells me is that this graph is not a linear trend, because you have such a disparity, and when you hit 36 inches, based on when you start looking at this data, it means that this data does not fit a straight line. And so that's when I go over to the exponential regression, exponential analysis, to see how things go into the future. And this is when you start looking at it and it's like, wow, this is kind of nuts. But you can see by 2025, so this is taking the exponential function, this is taking the growth function here in Excel, and I'm looking at the data from 1895 through 2016, and you see in 2025, it's almost at 12, about a foot of sea level rise. By 2050, it's a foot and a half, and then by 2075, we see a huge jump there. It's already over 2 feet of sea level rise. And by 2100, you're basically at a meter of sea level rise. And these last two here, 1953 and 2000, they're not really that important. It's just to show you that, look at the difference here between these numbers, 2200, 241, and then year 2200 here, 95, and then year 2200 here, it's 151. So what this is saying is that when you look at it at 1953, okay, what's seen, okay, what the Excel exponential growth function is seeing is that from here onwards, it doesn't look very exponential. It looks like a straight line because you're missing all this data back here. But then when you go back to 2000, and start there onwards, it picks up this little bit of jump here that we've hit, okay, and just in the last 5 or 10 years, there's been, if we kind of really just kind of summarize this whole graph, it's like there was one kind of turn, maybe around 1940, 1950, where it went from one slope to another slope. And then really just in the last 10 or 15 years, it made another turn going up at an even faster rate. So it's kind of made two turns since the Industrial Revolution. And so we have to give it some time here and see how this last turn ends up panning out. But either way, sea levels, I think it is fair to say that sea levels are rising, and it's at an increasingly faster pace. So we'll have to see how this pans out. But hope that makes sense, and thanks for watching.